This is lesson 3.5, quadratic function models. When you see the word model, it usually means you're modeling a word problem, or you're taking a word problem and turning it into a graph or an equation. Some of the most common word problems are asking us, in one way or another, either find the zeros or the vertex. The question might say a publishing company wants to make as much money as possible. Okay? When you see that as much as possible or something like that, it's talking about a vertex. Or if it's asking when will the rain hit the ground, when something's hitting the ground, then you're looking for zeros. Your task is to find out what the question is asking and find it. So you have this chart on your handout, if you've printed out the handout. We're going to go through every cell in this chart here. So let's start with if we have standard form and the question is asking us to solve. That's the same as the question saying, what are the zeros, or find the roots, or what are the x-intercepts? These are all the same thing. So if you have a question in standard form and the question is asking you for, when will the rain hit the ground, for example, that would mean finding the roots. So there are two ways to do this. You can either factor if it's factorable. If you can't factor it, then you're subbing into the quadratic formula. So what if the question is asking for a max or a min, like that's a vertex. If it were saying, when will profits be at a maximum? So if we're looking for the vertex, we're going to have to complete the square. That's one way to do it, complete the square. The other way is to use that little kind of formula thing here. You can sub into that. That will give you the x value of the vertex, and then you would sub whatever you got in there to find the y value. So if you got x equals 7, then you'd put a 7 up here for x's, f7, and that would give you the rest of it. The last part is the y-intercept. When you're in standard form, the only thing that's easy to find is the y-intercept. Everything else requires work. All these are lots of steps. The y-intercept is easy because it's just this c value here. You're going to sub in x equals 0, so put a 0 for x, a 0 for x, a 0 for x. This all turns into a 0, so it's just the c value. So that's the easiest thing to find is the y-intercept. The next is when we're given a question already in vertex form. Usually we don't have an a and a k for quadratics because they make the graph do the same. It looks the same. So usually it's a or k, but I put them both in here depending on what they give you in your textbook for a question. So you get a question in vertex form, and you are asked to find, for example, again, when does the rain hit the ground? So you're going to have to expand it back to standard form. You're going to have to make it look like this. Once you do that, you're back to that cell there. So you're in standard form, then you can do one of these two things. If you have vertex form and you have to find a max or min, that's the easy one because it's already in vertex form. This is the x value of the vertex, and this is the y value of the vertex. If you have to find the y-intercept, this c right here and this c are not the same. Unfortunately, your textbook uses c's in two different ways. This standard form c, what we did here, is not the same. If I sub in x equals 0 here, sub in x equals 0, the answer is not just going to be this c. So it's not exactly the same outcome, but you're still subbing in x equals 0 because the y-intercept is a coordinate on the y-axis where x is equal to 0. Factored form. You get a question in factored form and you have to find out when the rain hits the ground, for example. That's the easiest one for factored form because the s and t are the zeros. You're just looking at what makes this bracket 0, what makes this bracket 0. So let me just clarify there. Our brackets don't always look like that. We could have, say, -2, 3x plus 1 maybe, and plus 1, sorry, and x minus 5. All right, that's factored form. This one's easy. This one tells me I'm going to have an x-intercept when x is 5. But this one's a little harder. So I'm going to take 3x plus 1. I need to find out when that bracket will equal 0. So I would solve that, bring the 1 over, and divide both by 3. X equals -1/3. So it's not just as straightforward as s and t. Sometimes you have to do a little bit of calculations. What you're really thinking of is what's going to make this bracket equal to 0, and then that's going to be your x-intercept. To find the max or the min, you are going halfway between your zeros. So whatever your two zeros are, if these are your zeros here, halfway between your two zeros, that midpoint, that will be the axis of symmetry, and then find the y value. So if you have let's say here's our graph. We have an x-intercept here at 3. We have another x-intercept here at 1. Well, then the axis of symmetry is going to be right here at 2. When x equals 2 will be the axis of symmetry. That means the vertex is going to be somewhere on this dotted line. Maybe it will be up here, and that would mean the graph would open down. Maybe it would be down here. But to find that, you sub in. So once you find the axis of symmetry, same thing that we had over here, you have to then find the y value by subbing in. The last one is to find the y-intercept in factored form. It's the same thing. We sub in x equals 0. That gives you the y-intercept all the time. That's the one that's the same. It's consistent no matter what type of format you have. You're subbing in x equals 0. So I'm going to give you a few sample questions here, and some of the answers are going to be find the x-intercepts, find the vertex, find the y-intercept, which we just had in our chart, but some of them are a bit different. So if a question asks you for the break-even point, what are you looking for? Break even. So you need to know a little bit about, maybe if you've taken an accounting course, you know that break even means you're not making any money, but you're not losing any money. You've broken even. So that would be the x-intercepts. X-intercepts would tell you when you have broken even. No positive, no negative. That's it, right on the 0. That's the x-intercept. If it asks you for the area of a rectangle, okay, I put this in because I'm surprised at how often the students forget. They throw in the area of a triangle instead, 1/2 base times height, but the area of a rectangle is just length times width. If the question asks you how long a baseball was in the air, what are you looking for? Okay, a baseball being in the air. So we've got, let's say here's the ground. The baseball gets hit, probably not hit at the ground, it's probably hit a little higher up off the ground. The baseball gets hit and it lands. So this would be the y-axis here, and this would be when it lands. So we need to find the time in between those. Time. So from the time the ball is hit, that's the y-intercept you need to find, until it hits the ground. That's the x-intercept, but just one of them, because there would be another x-intercept back here somewhere. Right? If you do the quadratic formula, you'll get another answer here, but this one is inadmissible. We don't need that one. And if it asks you, how can you represent the sum of the squares of 2 consecutive integers? Okay, so first of all, let x represent the first integer. The sum of the squares, okay, sum means I'm going to be adding something. Squares means I'm going to have whatever my number is, I'm going to have square it. Consecutive means consecutive integers are one right after the other. So if one number is 5, then the next number has got to be 6. One right after the other. So if my x is my first integer, then my next one's got to be x plus 1. That's how you do consecutive. And you want the sum of them. So here's my first integer, here's my second integer. I want the sum of them. I don't just want the sum of them, I want the sum of their squares. So I'm going to have to square this and square this. And that will give me the equation, or that will give me an expression to start with to solve the question. So this is a pretty fast lesson. We're almost done here. I want to get you started on one question that's in your homework. It's page 178, number 8. It says the population of a region can be modeled by this function. T is the population in thousands, and T is the time in years since 1995. What was the population in 1995? So this is wrong. This is wrong. The question says, what is the population in 1995? So that's time, right? I am not going to sub in this and then do my whole equation and put a 1995 there, squared, and so on. That's wrong. So can you think of why that's wrong? Hopefully you did think of why it's wrong and you came up with the correct answer, which is the question says time is in years since 1995. So this model, this equation is only good starting with 1995. So to find the first one, I would be putting in population at time 0. I would want a 0 for that one. So for 2010, I'm not going to sub in 2010. I'm going to have to subtract 2010, 2010 from 1995. And I'm not going to give you all the answers here, but that's how you're going to finish that question. That's it. That's a quick kind of 10-minute video. It's a recap on what we've done so far in quadratics. Most of this is grade 10. So do the word problems, just work on them slowly and use this page to help you when you are not sure what the question is asking. Good luck. Let me know if you have any questions.